10, we are finding the roots of a polynomial. The roots of the polynomial just means find the answers where this equation is equal to 0. This equation again is written in factored form, so either this factor can equal 0 or this factor can equal 0. So w squared plus 3w minus 10 could equal 0, or 4w minus 32 could equal 0. Then we're going to just solve each of these problems as appropriate. The first one is a quadratic expression, has that squared term, we solve it by factoring. So w and w, my signs. Since the end is negative, I've got 1 plus and 1 minus. I want the factors of 10 that when I plug them in, the outside plus the inside adds up to 3. So I would have to have 5 times 2 is 10, a positive 5 and a minus 2 would add up to the positive 3. Since we have the equal 0 then, either w plus 5 could equal 0 or w minus 2 could equal 0, and I have to move my numbers over so I get the opposite answers. So here I'm going to minus my 5, here I'm going to plus my 2. So for this part we get negative 5 and 2. We still have to solve this one, so we solve that one. That one's just a plain linear function. It doesn't have the squared term. We're going to move our 32 to the other side. For w equals 32 and divide by 4, so w equals 8. So we'll add that to our list. And so our roots, our solutions, negative 5, 2, and 8. Number 11, same kind of thing. Wants us to solve for w, I should say solve for v. Let's fix that. I think my typist likes to copy and paste. Solve for v, solve for x. There we go. Wants us to solve for v. We have our two factors set equal to 0. So either the 7v plus 7 could equal 0, or the v squared minus 7v plus 6 could equal 0. So solving this first one, I'm going to move my 7 over. 7v equals negative 7, and then I have to divide. v is going to equal negative 1. Negative 7 divided by 7. The second one, quadratic expression. We've got to solve by factoring. Factors of v squared, v and v, my signs. The end is positive, both are the same as the middle, a negative and a negative. Factors of 6 that give me 7. Could be 2 and 3, but that doesn't add up to 7. Oh, so I got to use the 6 and the 1. A negative 6 plus a negative 1 adds up to the negative 7 in the middle. So v minus 6 could equal 0, or v minus 1 could equal 0. Again, we've got to solve those, so we change our signs. Add our 6 and add our 1, so 6 and 1 are added to our list. V could equal negative 1, positive 6, and positive 1. By the way, if something does repeat, you don't need it on the list more than once. So if I had gotten negative 1 twice, I would only put it in once. We didn't. Number 12, same kind of thing. Solving for x. My factors are equal to 0, so either the 3x minus 9 might equal 0, or the x squared minus 1 might equal 0. Solving my first one, I'm going to add my 9, 3x equals 9, and divide by 3. So x equals 3. Second case, again I have that quadratic expression. I know it came from foiling. Hopefully I recognize that's one of my special cases. It's the difference of perfect squares. Factors, x and x. Since this is a negative, a plus and a minus. And the factors of 1 that give us 0 x's in the middle, 1 times 1. So x plus 1 equals 0, or x minus 1 equals 0. Solving those, I get minus 1 and positive 1. So negative 1 and 1. Those would be my three solutions.